Photovoltaic Smart Agricultural Tool. Abstract. With the increasing necessity of reducing dependency of agriculture on fossil fuels, the utilization of alternate sources of energy is in great demand. Solar energy, being the most abundant source of energy in the country, is the most compatible source of energy for agriculture purposes. Solar energy can be utilized in different forms by the farmers to get a cost-effective and efficient alternative for their farming needs. The proposed project title intends to explore more in the field and develop a solar agriculture multipurpose machine which we call all-in-one machine. The machine is completely powered by solar energy, which performs various farming operations like weeding, spraying, pesticides, ploughing, etc. Keywords: agriculture, solar energy, labor, farmers, multi-operations, weeding. 1. Introduction. Innovation, being the heart of many technological advancement, has also found its way to the agriculture sector. Agriculture is a major sector of the Indian economy, accounting for approximately 17% of total GDP and employing more than 60% of the workforce. 5. According to the World Health Organization, officials are concerned about slow agricultural growth because rural employment employs 2/3 of India's population. Agriculture is India's backbone. With increasing fossil fuel prices, it is not affordable for the farm owner to hire a tractor for his routine operations. Most of the cases, farmer could not recover his entire money that he spent during seed sowing, harvesting and field preparation. This is accountable for suicides. Also, unexpected rains play an important role here. A significant quantity of energy is consumed in agriculture to accomplish various field activities such as ploughing, irrigation, spraying of agricultural pesticides, harvesting and post-harvest processing, and so on. Energy security is critical for a country, and attempts are being made to use renewable energy sources, mostly solar energy, as fossil fuel-based energy is depleting at an alarming rate. After considering all of the issues, whether they be labor 1, skilled labor, energy efficient and cost, we decided to develop a system that will run on photovoltaic solar energy and be capable of performing operations such as ploughing, weeding, seed sowing, cultivation, and so on in a single machine. A problem statement. From the literature survey and the information we had, we found that most of the machines available in the market are intended to serve a single purpose, and most of them were powered by IC engines. 5. Considering today's scenario of prices and dependency on fossil fuels, we decided to find an alternative for the same in the form of solar energy, which is the most compatible one for our application. Using solar energy machine could perform all the operations with the help of provided attachment. This will address problems such as low yields, extra efforts and higher costs for farming operations. B. Objective. 1. To build a machine capable of performing a variety of operations. 2. To move from non-renewable energy to clean renewable energy. 3. To build a machine which will suitable for small-scale farmers. 4. Increase efficiency of work and reduce operation cost and time. 2. Methodology. Factors influencing design. 1. Soil resistance. Resistance offered by soil, kg/cm. 2. 2. Velocity of machine. Velocity with which the operation is carried out. 3. Row-to-row spacing. Spacing between the two successive rows. 4. Cross-sectional area, the area which the equipment penetrates in the soil. A. Construction and machine layout. The construction of a core machine looks like a two-wheeled tractor with 3 main components. Main body. Transmission unit. Handle. Main body. On the main body we mounted all the necessary parts which are used, such as the motor, battery, belt drive, etc. Transmission unit. The transmission unit consists of a gearbox, wheels, and entire transmission parts. Handle. Handle acts as an armrest for farmers and also helps him in guiding the machine in a straight path. A. Working. The entire machine is powered by an electric motor which operates on solar power. For speed reduction, belt pulley arrangement is used. The speed of the motor is further reduced by the single speed reducer gearbox. Gearbox further powers the two wheels attached. Agriculture tools are attached at the backside of the machine. Handle is used for hand rest of the farmer. B. Material selection. For chassis and machine structure we used general purpose mild steel with properties given below. Yield strength, 250 MPa. Ultimate tensile strength, 400 MPa. Density 4850 kg/m²3. For farming tools grade A Corten is selected. It is commonly known as weathering steel or atmospheric corrosion resistant steel, and is specified in accordance with N 10025-5. Corten is a low-cost option for structures that are subjected to extreme weather and high shocks. For farming tools we required the same properties, so this material was selected for plow and star tool. 3. Design procedure. A. Power calculations. Considering a depth of 16 centimeters. The soil resistance of 0.8 kilograms per square centimeter. The speed of the machine was 1 m/s, width of 20 centimeters. Cross section equals 20*15 equals 300 cm2. Force equals 300 times 0.8. Total force equals 290 kg, 50 kilograms additional weight considered for design safety. Power equals 299.81 equals 2844 watts. B. Motor selection. Motor with the following specification is selected from the power calculated. Motor specification. Brand. Tsuyo. Voltage. 48V. Power source. Electricity. Power. 1000 W. Speed. 2850 RPM. Motor type. BLDC. Type. Externally excited. Torque. 18 nanometers. C. Transmission design. 1V belt pulley calculation 6. While selecting the belt pulley arrangement, maximum speed reduction ratio was considered in order to bring the speed of the motor to a desired value at the input of the gearbox. Belt drive ratio equals 10. D2/D1 equals N1/N2. D2 equals 500 mm. D1 equals 50 mm. 2. Gearbox design 6. Electric motor power P equals 4.1 kilowatts. Motor rotational speed Nm equals 2000 rpm. Belt drive ratio UB equals 10/1. Gear ratio UG equals 6/1. Gear input operating conditions, uniform. Gear output operating conditions, high shock. A running time of the reducer, T equals 3 hrs/day. From the given input parameters, center distance of the reducer should be 180 mm. Tooth number of the pinion 1 equals 25. Tooth number of the wheel is 2 equals 1, equals 24. 6 equals 144. Module, M. Calculating bending moment and output torque for both driver and driven shaft. A. Bearing for high-speed shaft. From given input parameters, a bearing of 63010-2 Rs1, from SKF catalog we have selected. C. Bearing for low-speed shaft. From given input parameters, a bearing of 61812, from SKF catalog we have selected. D. Bearing dimensions. Fig.5. For modeling. Designing in SolidWorks, figures below show the different parts of the machine. Each and every element is designed and modeled using SolidWorks software with appropriate dimensions. A. Chassis. Fig.6. Chassis houses the motor battery arrangement and belt pulley arrangement. The main function of the chassis is to carry motor and battery without any failure. B. Transmission unit. Fig.7. Transmission unit consists of a motor belt pulley arrangement, gearbox, and axle. The motor is connected to belt pulley arrangement, which is further attached to the gearbox. C. Handle. Fig.8. Handle is used for armrest and modeled as shown in the fig. D. Machine assembly. A. Assembly with rubber tires. Fig.9. B. Assembly with steel wheels. Fig.10. The main machine consists of the chassis, transmission unit, and the gearbox assembly. E. Plow tool. Fig.11. Plow tool is used for plowing operation. The solid model is as shown in the figure. F. Star tool. Fig.12. The star tool is generally used for soil preparation and weeding purpose. Solid model is as shown in the above fig. G. Insert pin. Fig.13 Fig.14. Insert pin is used to attach the farming equipment to the main machine. Lock pin is used to lock in the insert pin and fix it. The solid model is as shown in the above fig. H. Final assembly. I. Assembly with plow tool. Fig.15. Assembly consists of a main machine and plow tool attached to it as shown in the above figure. 2. Assembly with star tool. Fig.16. Assembly consists of a main machine and star tool attached to it as shown in the above figure. I. Solar panel assembly. 5. Electrical system. A sun-mobilular panel, sun electric powered panel, photovoltaic, PV, module or simply sun panel is an meeting of photovoltaic cells hooked up in a framework for installation. Solar panels use daylight as a supply of electricity to generate direct modern energy. A series of PV modules is known as a PV panel, and a device of PV panels is known as an array too. Arrays of a photovoltaic device deliver sun energy to electric equipment. Monocrystalline, or mono, sun panels are crafted from skinny silicon wafers, which might be reduced right into a recognizable cylindrical shape, taken from artificially grown crystals. Efficiency prices for this form of panel are commonly among 15 and 24%. They may have blessings along with an extended lifespan than different varieties of panel and being greater area green as they yield the best quantity of power, which means you may require fewer of them for the equal output. Polycrystalline, or poly, sun panels also are crafted from silicon wafers from artificially grown crystals. However, instead of being taken from an unmarried supply, they're made the usage of many interlocking crystals. Visually they're distinguishable from mono panels as they're reduced in square shapes. This form of sun panel is less expensive, however commonly gives barely decrease efficiency, around 13 to 18%. Components of the solar power system. A. Solar panel. B. Solar regulator. C. Inverter. D. Battery. A. Circuit and working. Fig.17. The sun panel converts daylight into DC energy to rate the battery. This DC energy is fed to the battery through a sun regulator, which guarantees the battery is charged nicely and now no longer damaged. DC home equipment may be powered immediately from the battery, however AC home equipment requires an inverter to transform the DC energy into 240-volt AC power. Some DC home equipment may be linked to the regulator to take gain of the low voltage disconnect and defend your battery. B. Calculation. 1. Calculate loads. In order for you to size the system correctly, you need to note the power rating of each appliance that will be drawing power from the system. For this example, we will calculate the power requirements for our smart machine. Bulb equals 5*15. Electric motor equals 1*1000. Calculate loads. Total load equals, quantity, watt, no. Of hours per day. Equals 5*15 2 plus 1 1000*3. Equals 3150 Wh/day. 2. Solar input. In India, average sun peak hour is 5.2 hour per day. 1. Required solar panel input equals 3150 Wh/5.2 H, 1.4 equals 848.88. Note, the 1.4 used in this formula is a factor we have found that can be used to simplify the calculations for basic systems. 3. Select solar panels. Select solar panels to provide a minimum of 390 W. Always best to go bigger if possible. Number of solar panels equals 3. 3*390 W solar panels chosen which, when connected in parallel, will provide 1170 W. Type of product. Table number 6 Solar panel specification. 4. Select solar regulators. The rated quick circuit modern of the 390 W sun panels is 3.01 amps each, giving a complete of 9 amps. Select a sun regulator. This is extra than able to coping with the whole quick circuit modern, 9x 1.25 equals 10.22 amps. Stick a 20 amp regulator chosen. Note that, as defined with inside the notes above, you ought to permit 25% greater potential with inside the regulator score, as sun panels can exceed their rated output in particular cool sunny conditions. A 20A regulator will permit for a further panel with inside the future. 5. Select inverter. Select an inverter that is more than capable of supplying the maximum anticipated combined AC load required. Our appliances are DC operated, so we have not selected any inverter. Note, a pure sine wave inverter is the preferred choice, but if the budget is tight, a modified sine wave unit could be used. 6. Select battery. Select a battery, or a matched aggregate of batteries. This is able to present the full energy utilization without being discharged greater than 70%. In maximum instances, it's far encouraged that the batteries are sized such that they've around 3 to 4 days backup potential. This lets in for days with low daylight and decreases the each day intensity of discharge, ensuing in longer battery life. With 1 day's garage potential and voltage of 48 V, the battery sizing could be as follows. Are required equals 3150 Wh*1/48 V, /0.7 1.1 equals 70.5 Ah. Note, the 1.1 is used on this system as batteries are commonly handiest, approximately 90% efficient. 6. Analysis. Static structural analysis turned into achieved for the vital elements which make contributions to the essential power and may be taken into consideration as structural elements of the system. This makes use of finite element analysis with the aid of using growing right meshing. We have evaluated the whole deformation and pressure attention with inside the given elements. 1. Chassis. 1. The maximum deformation of the chassis is at the front part, which is 3.851 E5m. This deformation is due to the front load acting on the chassis. The deformation is negligible and doesn't affect the structure. 2. The maximum equivalent stress is 1.0977 times 10 to the power of 7th Pa, which is at the rear joint part of the chassis. The values are within the permissible limit. 3. The maximum equivalent elastic strain is 5.9396 m/m. The values are in the permissible limit. 1. The maximum deformation of the plow tool is at the side curve plate, which is 0.00234111 mm. This deformation is due to the resistance force act due to soil. The deformation is negligible and doesn't affect the structure. 2. The maximum equivalent elastic strain is 0.001973 mm per millimeter. The values are in the permissible limit. 3. The maximum equivalent stress is 3.6055 times 10 to the power of 8th Pa, which is at the bottom and joint part of the tool. The values are within the permissible limit. 1. The maximum deformation of the star tool is 0.64415 mm, which is at bottom point. This deformation is due to the resistance force due to soil. The deformation can be reduced when the force will be divided in the same multiple tools. 2. The maximum equivalent plastic strain is in the bottom tip point, which is 0.007169 mm per millimeter. The values are in the permissible limit. 3. The maximum equivalent stress is 1434 MPa, which is also at the bottom part of the tool. The values are within the permissible limit. Acknowledgement. It gives us immense pleasure and satisfaction in presenting this project report on photovoltaic smart agricultural tool. This report work has opened up new vistas of knowledge for us. We can now justifiably claim that this experience will stand us in good stead in the years to come. There are a large number of people without them this large and unique learning experience would be a non-starter. We wish to express our deep sense of gratitude to our internal guide Professor Sunil Chougule, Mechanical Engineering, for his valuable guidance and useful suggestions which helped in completing the project and this report work in time. Without his cooperation, it would have been extremely difficult for us to complete this report. We would like to take this opportunity to thank Professor Sunil D. Chougule for extending his kind cooperation and kindly help during our project and report work, whose guidance was like a driving force behind the success of our project. Words are inadequate in offering our thanks to Professor M.B. Jodhari, head of the Department of Mechanical, who has been the source of our inspiration and also for this timely guidance during our start of project to final report. We are grateful to other staff members of the department for giving us important suggestions. We also heartily thank our director Dr. Rajesh Jalnakar for giving us an opportunity to make work a success.